Hi everyone, in this video I'm going to teach you the basic concept of factorial notation. Now the reason why I'm teaching this is because you will be using this later on in um, solving problems in probability. Okay, let's begin with the definition. In math, there is a notation called factorial notation which uses the exclamation point. Now some examples of factorial notations are, so if we name that or we read that as 5 factorial, that is equal to 5 times 4 times 1, 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. 2 factorial is 2 times 1. 1 factorial is equal to 1, and 0 factorial is equal to 1. Okay. Here, notice that factorial notation means to start with the number and find its product with all the whole numbers less than the number and stopping at 1. So we formally define the factorial notation as this. So n factorial is equal to n times n minus 1 times n minus 2 times 3 times 2 until the last number, which is always 1. Factorial notation can be stopped at any time. For example, we have 6 factorial that can be equal to 6 times 5 factorial, or sometimes it can be 6 times 5 times 4 factorial. Now the reason behind that is because sometimes you have to stop at a certain number, and later on I will give you examples regarding that. So we can do this. We can stop anywhere. Okay, so let's solve some factorial notation problems. 3 factorial plus 4 factorial, what is that? So 3 times 2 times 1 plus 4 times 3 times 2 times 1. So actually in your calculator, you can just type 3 factorial and then it will give you 6, and then 4 factorial, it will give you 24, and the answer will be equal to 30. Okay? 8 factorial minus 7 factorial, you can straightly do this in your calculator, but if your teacher tells you to show your work, then this is the work. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 minus the 7 factorial. So that's this 40,320 minus 5,040, and that is equal to this one. Okay, this is going to be an easy topic. Number 3, we have 5 factorial times 2 factorial, which means that, right? And then that's 120 times 2, which is equal to 240. I will just encircle the final answer. Yeah, I did that here. Okay, let's go to the fourth one. So 7 factorial divided by 5 factorial. So here we can stop, right? So they are the same, so we can just cross them out. That will be equal to 42. Okay, so here we can stop at 6 factorial, and the reason behind that, because our denominator is 6 factorial. So we can cross that out, and this will be equal to 504. Later on, you will be also using this when you encounter permutation and combination in probability. So 8 factorial plus 2 factorial minus 7 factorial, which means this. This is your 8 factorial, this is your 2 factorial, and this is your 7 factorial. So that's equal to that one, which is equal to that. So the final answer is 35,282. Here we have this. So 5 factorial plus 3 factorial times 4 factorial minus 0 factorial. This is 5 factorial, this is 3 factorial, this is 4 factorial, and 0 factorial is equal to 1. So that will be equal to that one. That will be equal to that. So the answer is 2,898. Okay, let's go to the next one. So we have this. That is equal to this one. So here you notice I stop at 7 factorial because that's the highest number in our denominator. It has 7 factorial also. So I can cross that out. And then I can also divide 8 in 2, which is equal to 4, right? And that will give us 9 times 4, which is equal to 36. Okay. Let's have another one. So here, I know you're thinking, that's right, you're going to stop at 6 factorial in the numerator. So you can cross that out. What else we can cross out? We got 8. 4 times 2 is 8, right? and then this is 3, which is 9, that's 3. So 10 times 3 times 7, which is equal to 210. Okay, let's go to the next one. This one. So 12, 11, 10, 9, 8, 7. We stop at 7 factorial because of that. And then 5 factorial is 5, 4, 3, 2, 1 times multiplying them. So here we can simplify, I think 5 and 2, that's 10, right? And then 4 times 3, which that's equal to 12. So that will leave us 11 times 9 times 8, which is equivalent to 792. Oh, there you go. That's it. That's how we uh, solve factorial notation problems. It's easy, right? Thank you for watching, and you're going to apply the concept of this one later on in some of the lessons in probability. Okay? Thank you for watching. Bye.